Hello and welcome to Motion Along a Straight Line. In this video, I'm going to introduce you to the equations and some of the concepts that we will need to solve problems in this chapter. So our first equation on the equation sheet is one for displacement. So this is along a straight line, so you could think of a car moving along a road. We can look at its final position minus its initial position to get the change in the displacement. So to have an initial position and a final position, I really need to do an important first step for every problem in physics is pick an origin. So the moment I pick an origin, I have just said that the location at the initial location is at 0, and then my final is going to be however far away. I could say that this location right here on the floor is the origin, and if I walk over here, let's say a meter away, I can calculate my change in displacement. It's going to be 1 meter minus 0, so 1 meter. If I started here at my origin, 0, and I moved a meter that way, I would have an initial of 0 and a final of -1. So then my change in displacement would be -1 meter. If I started at the 1 meter mark and moved a meter that way, my final is 2 meters, so 2 meters minus my initial of 1 meter gives me 1 meter, so I would have moved a +1 meter. So that's if I put my number line along the x-axis. My one-dimensional motion doesn't have to be in the x direction. It could also be in the y direction, and in those situations we can switch to using y if we want. So I'm looking at a side view here of let's say a building, and I want to think about a ball that I might drop and describe its motion in that one dimension. I'm going to again need to pick an origin, and I can put the origin anywhere I want. I could put it at the top, or I could put it at the bottom. Those are usually good picks, putting it at the top or the bottom, and it's not going to change these equations. It's not going to change the result. So you could put the origin here, and your neighbor could put the origin here, and you should end up with the same answer. And the last way that we're going to think about motion in one dimension is going to be a drone view. So let's say we're looking down on campus. This is a building, and maybe that's a patio, and I have a sidewalk that connects them that's straight. So in this situation, I'm gonna rotate my axes, and the way I've drawn it, I've made it such that I have an X as my motion direction. All right, we're gonna move boards. So building on displacement, I can use the change in displacement divided by the change in time to get my average velocity. So that's what that line over the top means, that it's an average velocity. So if I drove 55 miles an hour from here to Altoona, I could calculate I could relate these variables, how far it was and the time it took me. So if I knew I went 55 miles an hour and I knew how far it was between the two locations, I could use that to solve for how long it would take, the time. If I have a change in velocity divided by change in time, that gives me the average acceleration. Again, the bar over the top is signaling that it's an average. If we're dealing with free fall motion, like when we were thinking about a ball falling through the air. If it's in free fall motion, then the acceleration is gravity. That's what causes an object to fall. Gravity. And gravity always points down, so I could label that, maybe my gravity vector always points down. The magnitude of gravity is 9.8 meters per second. And we're gonna talk about that a lot the entire year. Gravity has a magnitude. When I say that word magnitude, what I'm meaning is absolute value. We're not gonna worry about the plus or minus of 9.8 meters per second squared. When we put it into equations though, we need to put the negative sign because we know it's acting down. All right, next equations. These are the kinematic equations, and these relate the quantities I've been talking about: displacement, velocity, and acceleration and time. So this equation says the final velocity is the initial velocity plus the acceleration times time. We can use these together to, given certain initial conditions, predict a final value or a later value. So I have a couple of things to remember before we start doing problems. Remember that the square root of 4 is plus or minus 2. A lot of times people will make an error in some of the problems we're going to work in this unit. There's a moment when you need to pause and think, is it positive or is it negative? Recall that distance and displacement are different things. So I haven't said it yet in this video, but it was in the textbook. Distance and displacement, the difference, I like to think about my wearable device. If I walked out to the quad and I hit start doing a run or a walk, and I ran all around campus and I ended back up in the exact same spot where I left and hit stop, my displacement is 0. Because I'm going to use the equation that we introduced at the beginning. Delta x is x final minus x initial. What was my final location? Right here. What was my initial location? Right here. So final minus initial is 0. So my displacement would be 0. But I know I ran. So my distance, that's what my wearable shows me. So my distance is the actual path that I went on. But in these equations, this is displacement. Delta x is displacement. If the velocity isn't changing, which we will have that sometimes, then the acceleration is 0, which it would come out of the pink equation that we talked about earlier. All right, one last thing. I'm gonna head over to this other board. When I have an object that is flying through the air, let's suppose I threw a ball up in the air and it's gonna take this path. So it'll go up, 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 up. It'll hit the top and then it'll come down, 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 down. At the instant that I threw it, it has a velocity that is positive. So it's going up. This again, if I'm gonna put my origin right here, it has upward motion, but as it goes up, it goes slower and slower and slower because gravity is pulling it down, negative. Gravity's negative. So at the very top, the velocity is 0. And this is an important conceptual idea that's gonna help make solving a lot of problems easier. So the velocity at the top is 0, just for an instant. But then it's gonna start coming down. So now, this is my arrowhead. I was going up, lower and lower and lower. I have an instant where it's 0, and now I'm gonna come back down faster and faster and faster. So at the bottom, it's gonna have negative velocity right before impact. Right before impact. And so that brings up an important point in this chapter. We are covering kinematics. Kinematics is describing the motion of particles. Dynamics, which we'll study in a few chapters, is the causes of motion. So what causes something to start moving or stop moving. So in all of these problems, when we think about the final velocity, we're really talking about right before impact. Right before impact. We will later on talk about when there's a collision and the motion changes. But for all of this chapter, we're looking at kinematics, the description of motion. Thank you. And I hope that this was a great start to your conceptual understanding. And I'll see you for problem solving.